Stan Gibilisco here, proprietor and operator of amateur radio station W1GV, Whiskey 1, Good Vibrations. I'm going to show you a simple method of inverting a single sideband signal. That means if it's lower sideband, you can convert it to an upper sideband signal, although at a different frequency, and vice versa. So here are the assumptions that we have. We have an input single sideband signal, say upper sideband, and it's right side up, so it's really upper sideband. It's what we want. If we mix that with a local oscillator signal, a carrier signal that is greater than its frequency is, we'll get a difference mixer, and the result will be the difference between the local oscillator frequency minus the input signal frequency. When we do that, we tend to invert the sense of the sideband. As an example, suppose that the carrier wave of the single sideband signal is 3 megahertz. So this is a 3 megahertz signal, suppressed carrier frequency of 3 megahertz, upper sideband signal. Suppose the local oscillator is 5 megahertz, just a plain carrier. Then the output is the difference. We choose the difference output, not the sum, but the difference output, which would be 2 megahertz suppressed carrier frequency. Now when we do that, we end up subtracting the input signal suppressed carrier frequency from the local oscillator frequency. And that tends to reverse the sense of the sideband. Again, if we have an upper sideband signal at 3 megahertz, suppose that we change that to 3 megahertz plus 1 kilohertz. Then the difference here will become 2 megahertz minus 1 kilohertz, because we have reduced the difference between the local oscillator and the input signal frequencies by 1 kilohertz. And so you can see that for any kind of single sideband signal, be it upper sideband or lower sideband, the difference mixing result will produce a signal with a sideband in the opposite sense, although again at a different frequency. Of course, we can always convert that to a signal at any other frequency, just making sure that we don't invert the sideband again. And that would mean then that the input signal frequency should be greater than the local oscillator frequency if we difference mix, or we can simply sum mix the two signals. But again, that's how it works. I hope I've managed to explain this. It's really quite a simple process, although very difficult to explain adequately. When you difference mix signals, and one of them is a single sideband signal with a lower frequency than the frequency of the local oscillator, when you difference mix those, you will invert the sense of the sideband and thereby obtain LSB if you started with USB, or USB if you started with LSB, although at a different frequency. Does that make sense? Stan Gibilisco, don't answer that. Stan Gibilisco, W1GV, Whiskey 1, Good Vibrations, saying 73, and so long, which, irrelevant to this discussion because I would always use CW, translates to da-da-da-da-da-da.